globe Earth. This is the globe. This is the globe. Planes flying on the globe, right? So pretty simple. We all understand that on the Mercator projection, here's going to look it's straight, but the fastest path on a ball is curved. Obviously, right? You go from point to point on a globe. The fastest path is a curve.
Yes.
That's the shortest path. It's called a geodesic. All right. So there we go. Now check this out. This little blue dot is our starting position. We're going to fly to the red dot. Okay. So in reality, what we do is this plane takes off from the blue. Can you see my cursor?
Yep.
I hope you can see my cursor.
Yeah, we
All right,
see.
cool. So in reality, what we do is the plane takes off from its starting position, and then it flies to the destination by keeping the city, the actual destination, in its heading. It just places its heading on the destination and flies straight there. That's how we do it in reality. Now, on the spinning globe, what you would actually have to do is if you just keep it on the heading and fly straight there, what you would be doing on the globe is this path right here. You would be slowly updating because it's moving away from you. Okay, so as you fly towards the destination, you're going to have to update, like a drone on a merry-go-round trying to reach the person. Okay?
Wow, I've never even thought of it like that. That's awesome.
So the way we actually fly the plane is we go from point A to point B. With the heading on the destination. If we were doing that on a globe that spins, then that means what the plane's actually doing is updating. Okay? But of course, the shortest path, if that was the case, would be to lead the object and then go in a straight line towards it. Right? So it's like if I have two missiles, one's a heat-seeking missile, one's just a normal missile, and an object's flying away from me. If I shoot the heat-seeking missile, it's going to follow it and update and try and track it down. If I shoot the other missile just leading where it's going to be, the missile I shoot that leads where it's going to be is going to be a shorter path. Because the other one's curved, right?
Yeah, absolutely.
Yeah. Okay, so if we really lived on a spinning ball, planes would not fly just with the heading on the destination because they're flying this long, drawn-out, corrected path where they would be saving billions of dollars in fuel to fly straight and leave the city.
Well, yeah, so if you're in New York up there and you want to go down to Brazil, you would start off flying straight east.
Correct.
Which would make no sense at all, you know?
Yeah, if you were to just flip this over, you could put, say the city's up here. Well, then this plane would just fly straight down and meet the city coming towards it.
Yeah.
We don't fly like that. Now that's when they try to claim that the atmosphere moves with the Earth, but not in lockstep, which means that there's Coriolis and it moves separate. Any bit separate at all, you're flying thousands of miles. You're going to update. So literally, this proves that we fly planes on a flat stationary plane because we fly.
They wouldn't waste the fuel like that. Yeah, they wouldn't waste the fuel. Like you said, they'd know where it's going to be, and they'd take off at that heading and just go straight in that direction.
Yeah, it's even worse than that. When we fly from this point to this point, the plane's not constantly adjusting for Coriolis in a singular direction. It's not banking that direction. Then you can get into all kinds of problems if you're flying a certain direction and have to bank the opposite direction. Obviously the plane can't fly to the west and bank to the east at the same time. So anyway, this actually debunks the globe. A great meridian north to south flight, the Earth spinning underneath it. Even if they try to claim the atmosphere moves with it, it technically moves separately. And in fact, it would lag behind the Earth the higher you go. And so yeah, that's pretty much I don't want to get all the way into the weeds because I don't have a lot of time. But I'll say that part real simply. So if you have a circle and you draw a bunch of circles outside of it, obviously the circles are getting bigger. That would be the Earth's atmosphere. So obviously the radius of those circles get bigger and bigger and bigger the further out you go from the surface, which means in order for that air to move in a single rotation all in lockstep with the Earth, the higher layers of the atmosphere would have to be moving faster because obviously speed equals distance over time, right? So if you're doing the same time, there's one rotation altogether, but it's going a greater distance, then it has to go faster. Like if I run 100 yards in 5 seconds and then I run 100 yards or 200 yards in 5 seconds, then I obviously had to go faster to run the 200 yards in 5 seconds. Anyway, so that means it would be lagging behind the Earth. So long story short, planes would have to take, if what they say is true, they're actually taking this corrected path the whole way, going way out of their way, whenever their distance could be significantly shorter, just leading the object. And we fly just point to point, and that's because the Earth is not moving.
And that's why they teach them to think of it as it's not moving.
Yeah, even with their navigation, what people will say is like, yeah, but not for navigation. No, yeah, actually for navigation.
Yeah.